Alright, the rest of your hour is going to be pretty much working on looking at some questions that I had to hold back from you. If you remember, I always try to hold things back so I can focus on the content and then kind of get you used to it. So this stuff here is going to be dealing with the negatives that exist in your problems that you're going to see, and it's also going to be introducing some stuff we're going to be doing starting tomorrow. Now, looking at your test, and really I just looked at your test whenever I made this, but when I looked at your test that you're going to be taking in a couple weeks, I guess, most of these are on there, and we're pretty much almost done in terms of looking at what we have to be able to solve. I think that this is a doable test, but again, you've got to make sure that you actually work to get this stuff. One thing we haven't seen is this, and we saw it, but we really haven't seen it since last week when I kind of introduced it to you, and the other day when the other week when I told you that they existed. The key thing to remember, we do need x on the proper side, but we also need x to be positive. And so what you have to do here is you have to switch your sign and make x positive. When you make x positive, the sign must switch and the 8 must also switch. We are going to graph these and make sure we keep that in our habit. So again, make sure that everything on your paper is copied. This is a quiz grade that I'm giving you. Again, another 10-point quiz grade to help you out. Some of you have increased 4%. You don't even realize it already. But just keep on going and keep on doing what you're supposed to do. Anyway, the -8 goes down. Remember, this represents an open circle, and it goes to the left. Keep in mind, don't just give me a cheap shade. If I see a cheap shade, I'm not going to give you credit for this. I need you to practice to get ready for your test. So again, if you're giving me a picture that looks like this, then I'm going to go ahead and just not even give you the points, because I'm telling you right now, you have time to listen while you take the notes and take the notes the right way. I don't care if you shade this way. I don't care if you shade that way. Make sure that your shade is obvious. Otherwise, again, I'm not going to give you credit for this, and I'm telling you that right now so that you know what you need to do. Number 2, again, looking at what we need to make sure we're ready for. If we see a negative number attached to x, this is a negative number. It's just a, it's not a, you can't actually see the number, but like I said, the number is actually there. Let me zoom this real quick, or focus it real quick if you don't mind. Sorry. But the thing is, the negative in front of x is automatically saying that there's a negative value attached, and so what I want you to do again is switch the number, switch the sign, and switch the other number. Now it becomes an easy problem. We know that we just need to go ahead and divide by 5 and divide by 5. X comes down, sign does not change, and -2. Again, the sign doesn't change in most of the stuff we did, except for whenever there's a negative attached and except for whenever x is on the wrong side. But again, we'll talk about that as we go. Again, graphing this, we have a -2, closed circle, and going to the right. Again, the arrow here is pointing to the right, so we need to go that direction. The tip of the arrow here is on the left, which means we go to the left. Number 3, again, it does not matter what it looks like. If there's a negative sign attached to your x, make sure you switch it over. We want to turn this into x over 4. Don't forget to switch that sign, and then switch to 3. Now we do what we've been trained to do, which is if the number's on the bottom, you multiply by that number. These two things cancel out. X comes down, sign doesn't change. 12 comes down. Label your 12. Open circle. Again, the tip of the arrow is to the right side, so we want to make sure we go to the right. Number 4 represents probably about one of the worst situations you'll see, but as long as you take your time and organize what you're doing, I think you'll be fine. First off, there's a -x, and it's on the wrong side, but I would deal with the negative part first. We know that our x has a negative attached, so we are going to switch everything first. That's the first part. But the second part is, now that x is correct, or at least looking like it's supposed to, we will then flip it back around to get it on its proper side. And again, that is the part where you need to make sure you are careful in terms of doing whatever you're supposed to do. Everything in this chapter here, or not everything, a lot of the stuff in this chapter here doesn't have so much to do with your skill. It has more to do with just being careful and making sure you're not doing something that causes you to miss points because you rushed through something. 14 greater than -2x. Again, first thing I recognize is that on this x there is a negative number attached. You have to learn to see that and just kind of add it to your understanding. Again, now that we have gotten most of the solving back under control, at least for most of us now, now you just have to open your eyes and make sure you notice when things like this are happening. Again, this negative 2 is attached to x, so what we have to do is switch everything. So negative 14, don't forget to switch the sign, the 2, and the x. You then solve the way we know how to solve, which is to divide by 2. Again, in this situation, because all we did was move 2, the sign does not change, and x comes down. Now that x is on the wrong side, you bring your x over, you flip the sign because of that, and you bring down your, or switch your negative 7 over to the other side. Again, graphing this, negative 7, there's no line under it because 7 is not bigger than 7. And since the tip of the arrow is to the right, we're going to shade to the right. And then number 6, notice again there is a negative attached to your fraction with the x, so the best thing for you to do is to switch everything around. Now that we have it the way we want it, multiply by 7, multiply by 7. Negative 8 times 7 is negative 56. Again, moving numbers does not cause the sign to change. And x. But now that x is on the wrong side, bring x over, switch the sign, and bring over your 56. Graphing this, negative 56 goes here. Again, the line under it means that it's equal to, which means you include 56. And then this ends up on that side. So looking at this work real quick before we move and start speeding up a little bit, the sign switched here because it was negative, so the sign switched here. The sign also switched here because it was negative, but it did not switch when we moved the 5. So again, we had a negative x, the sign switched. We had a negative x, the sign switched. Again, we had a negative x, so the sign switched. It did not switch when we multiplied by 4. We had a negative x, so the sign switched. We moved sides and the sign switched. Those are the only two things that you need to worry about whenever you're doing this stuff, is making sure that if the value is negative and you switch the value on it, that the symbol changes directions, and if x is on the wrong side, that the symbol changes directions. So again, just making sure you're ready for that. 7 and 8 definitely represent a test question. Actually 7, 8, and 9 actually represent a test question, so just pay attention and make sure you get what's going on. In this situation, what happens is you have 9 minus x is greater than 12, and most of you, when you see this, are going to think to yourself that because this is minus, that you add 9, but do not forget to look at this 9 and understand that this 9 is positive. I hope that we're better at this after this week's activities, but this is a positive 9, which means that we want to subtract 9 from both sides. This goes away. And the second thing that happens is when you go to do that, you end up bringing down a regular x. But if you look at it, this is not a regular x, this is a negative x. And so when you bring that down, make sure you are careful when you do this in bringing down your negative x, bringing down your sign, and bringing down whatever it is. And then in the end, switch, switch, and switch as we go to graph this. Open because there's no line. The tip of the arrow is on that side, so we're going to go that way. Alright, so number 8. Again, looking at this, you got 15 is less than or equal to 6 minus x. What you want to do again is recognize we want to move to 6. Again, the game that we played the first day this week. 15 is on the other side. 6 is the number we're going to move. You have to make sure you recognize that 6 is positive because there's nothing in front of it. And because it's positive, that we will subtract 6 from both sides. 15 minus 6 is 9. Sign does not change. But again, do not forget that this x is negative. And as long as you don't mess up on that, I think you'll get this question right. I think a lot of these questions are really easy. You just have to make sure, again, you take some pride in what you're doing. Once we now see a negative x, we know that we have to switch our 9, switch the symbol, and switch our x. And then the last thing we have to do, because x is on the wrong side, is flip it all back around. Now I will tell you what makes this difficult for some people. And what makes it difficult, sorry, this is a closed circle because of the line. Tip of the arrows to the right. Hold on. It's not going that way, it's going this way. Tip of the arrows to the left. So it should go here, and I will tell you what I did to get this right. So what ended up happening is I recognized that this symbol is pointing to the left. I also recognize that X is on the wrong side, which means the symbol is going to have to flip. Then I recognize that X was negative, which means it's going to have to flip again, which means if you take a coin and flip it over twice, it goes right back to normal. So something told me I was supposed to be going to the left as I observed what was going on. That's what told me that I couldn't have been going to the right, because somewhere along the line I might have missed my flip. That's why you want to make sure that you use your observation as you go through this stuff as well. Number 9. Again, you see a negative number attached to X. And we don't have a lot of these as you look. There are only 2 more of these that I need to tell you about. This also, again, is a test question that you need to be ready for. But again, the only difference is you have to remember that this is a negative sign attached. Now, on the test for Chapter 2, you got away with it because if you just simply did a little bit of work, you used the equal sign doesn't change, everything worked out. But if you do not pay attention to this negative and you do not pay attention to this symbol, then you're going to end up messing up, because again, you have to remember that once 3/2 X becomes positive, the sign actually faces the other way. Now we do what we've been trained to do if you remember the fraction problem, which is that you have to multiply by 2. These two things cancel. 3x comes down, symbol doesn't change, with negative 18. Divide by 3. This is your answer, and again, to graph this, negative 6 is my number, open circle, tip of the arrow is on the left, so I will go to the left. Number 10, negative 4 greater than or equal to negative 2/5 X. Again, the first thing you need to notice is that there's a negative attached, and so we switch everything around. Now we want to say, okay, we got to get rid of this bottom 5, so we multiply by 5 here and here, which gives me 20 less than or equal to 2x. The next thing we need to notice is that there is a 2 attached, which means we divide by 2. And the last thing you got to notice, again, is that x is on the wrong side, and so you bring x over, you flip your sign, you bring over your 10. Again, the line means that this is closed. The tip of the arrow is on the right, so we go to the right. On your test, I think the majority of your solving questions are graph and solve and graph, which means that's why I'm trying to make sure that we get some graphing in, even on this worksheet where we already know how to graph, and you already should kind of have the idea because you don't want to forget what's going on with this stuff. Number 11 is also a test question. Again, I looked at the test as I picked these out because these are the things that we should know how to do, but again, we got to make sure we've got down. Now, what we learned yesterday was that whenever you have x's on both sides, that you have to move the smaller x. But I want you to pay attention. I hope that you did not do this already. But I want you to pay attention to the fact that this 2 is not smaller than that 4, because this is a positive 2 and this is a negative 4. And if you think about it, a negative number is always smaller than a positive number. Is negative 10 bigger than 6? No, because that's below 0 and this is above 0. And so what I want you to adjust your thinking for after yesterday is to recognize that whenever you have a negative and a positive, the negative number is the one that moves. And the way you move a negative is by adding it. Again, this is why yesterday was our last day to kind of review that, because now that you have it in your head, you should understand this is smaller because it's negative, and because it's negative, we move it using a positive, which means we actually get 6x plus 3. Keep the sign. That goes away with 9. You then subtract 3 from both sides, and you divide by 6, getting this answer. Again, graphing that 1, open circle, going to the right. Number 12, again, same thing. What you should recognize that you have x's on both sides, And so when you look at that, don't just assume 3 is smaller than 5. Recognize that this 5 is negative and the 3 is positive, which means that 5 is smaller. So we actually want to move our 5 again by adding 5, because negative 5 and positive 5 cancel. Don't forget to bring down your 15, your symbol. 3 and 5 make 8x minus 1. And again, from there you do what you've been trained to do, plus 1, plus 1. Divide by 8, divide by 8, and then flip everything around as we go. Graphing this again with a closed circle because of the line. Tip of the arrow is on the right side, so we go to the right side. All right. Number 13. Again, test question. This looks a little weird because it's out of balance and we're used to usually seeing like a number on both sides with only x on one side, but this is actually already set up to help you out. But I just want to explain, if you ever see a question like this, even if you were thinking, and you don't need to write this part, but just follow along with what I'm doing. If I saw 2x is greater than 5x plus 2, your first instinct would be to move 2x over here. But if I move 2x over here, that's one move. I would then have to move this 2 to that side, representing 2 moves just to get the variables by themselves first. Whereas if I had this situation and I simply move this, even though it goes against what I've been trained, if I simply move this, notice that I am, instead of moving the numbers away from x, since numbers are already over here, I'm just moving my x away from the number, and then all I have to do is this move to get it alone, which is one step. The fewer steps you have to do, the better. Plus, whenever you do this, you end up with something kind of weird. But my general idea on this would be anytime you have two variables and one number, just move the variable away from the number. So again, we will move the 5x, even though it's negative, or because it is smaller, but still it would be the best idea to move it because this is the only number in the problem. So 6x, copy the sign, was 24. Divide by 6. X is greater than 4. Open circle because there's no line and the arrow, and I didn't want to give you two of those because there was no need. So tomorrow, since we have time to do this and I don't want to bore you with the other stuff, tomorrow your chapter 3.6 preview, this is what we're going to be looking at. It's called compound inequalities. And compound inequalities are inequalities that are just two problems in one, and there's two different ways you're going to see it. One way you're going to see it is where you have two symbols in one, kind of like stacked up, which might look weird to you, but this is really easy. And the other one is where you separate your problem with the problem or, so you have one problem over here and you also have another problem over here. That's compound inequalities. It will be important, especially as we move forward, so make sure again you at least get the idea down. Your solving rules aren't going to change. Everything stays the same. The only difference is you have to make sure you pay attention to one thing on these. On this problem, you don't just have two sides. Like in this one, this is a wall. You have two sides. But in this problem on number 14, there are actually two walls, which means that there are 3 rooms now. And because there are 3 rooms, it means that whatever I do, I have to do 3 times. That's the only adjustment you have to make for these weird looking ones. You still look and say, I want to get x by itself, because this is by the numbers over here, the numbers over here, you want x by itself. So what we will do is subtract 1. We know this already. The difference is, instead of just doing it twice, we have to do it in all 3 rooms. So again, whatever I do to get x alone, I have to do everywhere. I draw my line. 12 minus 1 is 11. Again, the sign does not change. X comes down. The sign does not change, giving me 18. The other change is that when you graph it, there are actually 2 important numbers, so you want to make sure you put them in order. So 11 and 18 are my 2 numbers. Pay attention to the fact that the connector for 11 is an open circle. Pay attention to the fact that the connecting sign for 18 is a closed circle. And the last thing that should make sense is that x is between these two, so you will shade in the middle. Again, x is between 11 and 18, and so you want the values between 11 and 18. Alright. 15, again, just looking at this here, looks weird, but again, it just means that it's only because you have 3 rooms now, and so you still want to get x by itself. The rule we follow still is there. The numbers are attached, so we will divide by 5, but you must divide by 5 3 times. Bring down your number, sign doesn't change. Bring down whatever's left, sign does not change, and 7. But when you go to graph it again, now you have 2 important numbers. Make sure they're in order. 3 has a closed circle. 7 has a open circle. Again, the reason why is because the sign attached to 7 is open. The sign attached to 3 is closed. And again, x is between 3 and 7. And so we will stay between 3 and 7. Number 16. This problem here, same thing. It's just got 2 steps. This is home. If you ignore that part right there, what would you do? You would add 3. Well, it's the same thing. The only difference is instead of adding 3 2 times, you must add 3 3 times. 1 and 3 make 4. Leave the sign alone. 2x comes down. Leave the sign alone. 20 comes down. You now want to get rid of the 2. Again, the solving steps are the same. Divide by 2. You get 2. Keep the sign. X. Keep the sign. 10. Open for 2. Open for 10. And again, because x is in the middle, that's where you are. Alright. 3 more solving questions, and then we get into some word problems that you're going to need again for the test. OR is different, because with OR, you still solve it the way that you learned. Again, pretty much with OR, you work it out as 2 separate problems. So you work this out by itself. You divide by 3. X is greater than 4. You come over here because, again, it says this or that. So now you solve this by subtracting 2. X is less than 1. You still need both numbers, but again, the trick here is you have to have them in numerical order. 1 is smaller than 4, and so you have to label it this way. But with OR, you actually label both of them. Notice that 1 is an open circle, and it's going to the left. And notice that 4 is an open circle going to the right, which is the opposite of what you saw with AND, or with the other one. So again, with this one, when x is in the middle, you shade the middle. Typically with OR, it's going to be a hole in the middle, and then everything around the outside. But again, we'll talk more about that tomorrow. '18, same thing. It's OR, which means pretty much separate this into 2 problems and solve this. And again, this is what your test question is going to look like, just so you know. It's a simple question. Again, there's nothing really difficult about the solving. The trick is, can you make sure you don't make a silly mistake along the way? Because with this negative 5x, you have to remember that the safest thing to do is to switch it first, then divide, getting x is less than negative 2. Over here, again, this isn't really that hard to do. You divide by 3, you get x, you switch the sign, you get 1. But again, put these in numerical order. The negative is always smaller than the positive. Graphing this one, 2 is an open circle pointing to the left. 1 is an open circle pointing to the right. And again, OR usually has a hole in the middle. If you just try to remember that, again, you can do that. Like it's not really hard for you to remember stuff. The problem is that you usually don't want to remember it, or you don't want to do the extra work. But if you at least try to remember it, it's really not that hard to work with. This is your actual test question level thing you're going to see. And this one's tricky for a couple reasons, but we'll get to that. Negative 2x is 16. I'm sorry, it should be a positive 16. So cross that out. So what we have to do is switch this to be 2x. Switch this to be, the other way, and then negative 16, you then divide by 2, and x is less than negative 4. Over here, again, there's nothing wrong. Leave your 6, x comes down with negative 1. The reason this is tricky is because most of us think that 1 is smaller than 4, which it is, but negative 4 is actually smaller than negative 1, because if you look at a number line, notice that negative 4 is here and negative 1 is there. So negative 4 is actually smaller than negative 1 because you'd rather owe $1 than owe $4. Open circle, going to the left, open circle, going to the right. The last two questions are also a test question, just so you know. But again, it's going to pretty much be one of those where you've got to make sure you know what's going on. The minimum number of people required to operate a machine is 6. There can be no more than 20 people in a room. Write a compound inequality to represent the situation. This is a situation where you're talking about a range of numbers. And what you should do is always write the smallest number. The minimum number is 6, so put down your 6. The maximum number is 20, so leave room and put your 20. X is going to be in the middle. And since you want the numbers to get bigger, you want 6 to be less than or equal to X. And you want X to be less than or equal to 20. It looks just like the questions that we did here. So notice the sign's always going to be less than whenever you do that. So that's how we always want to do it. Use less than, put the number over here, the number over there, and then put the X in the middle. And the last one, the speed limit on a highway is 70 miles per hour. To ensure safety, there's also a minimum speed of 55 miles per hour. Again, they want a compound inequality. Start with the lowest number. The lowest number is 55 miles per hour. The highest number is 70 miles per hour. Put X in the middle. And again, use the less than, which is the one that looks like an L, because you can go 55 miles per hour and you can go 70 miles per hour, but your speed should be between 55 and 70. Now make sure that you answer the question at the end of this video so you can actually get your points. Other than that, have a good day, and again, we'll be working on this stuff tomorrow.